Hello everyone, let's solve this problem LeetCode number 199, binary tree right side view. Okay, so let's see the description of this problem. Given the root of a binary tree, imagine I'm standing on the right side of it and return the value of the nodes we can see from the right side and from top to bottom. So in this one, we can see if I stand here, the first level we see the rightmost tree node is gonna be 3. This level, the rightmost tree node is gonna be 3. No, this one is 1. This one is 3. And the rightmost tree node in this level is gonna be 4. So our result is gonna be 1, 3, 4. Okay, this is the example. Okay, so how do we solve this problem? So in previous videos, so I actually solved this problem using BFS. And another video, I used a reversed BFS. But in this video, I'm going to solve this problem using reversed DFS. Okay, so how do we do this problem? So first, we need a helper function, okay? So first, in this case, so we will start from the root. Okay, just 1 second. So we will start from the root, the helper function. The first tree nodes we are going to use is gonna be root is 1, right? So and the depth in this level is gonna be 1. Okay, so the result size, right now our result actually is empty. So we don't have anything. So the result is going to be 0. And then what we do here, because our result size 0 is smaller than the depth. Depth is 1. So, and then in this case, that means that's the first one. So first tree nodes in current level. So what we do here, we just add the 3 in here, okay? And then we will do the recursion. When we do the recursion, we start from the right node, okay? Not from the left node. We start from the right node, and the depths, because the depths become 2, okay? So we start from 3. Our depth is 2, and then our result. So our result size here is 1, right? So that means in the in this level. So that's the first tree nodes we are going to put here. So the result size here is 1. So what we do here, we will offer this one. We will add this one to our result is 3, okay? And then we will do the left, and then we will continue to do this one. So the depth of here is gonna be 3, and the right nodes here is 4, okay? So will be 3, and then the result size here is 2. So because it's 2, right? So because 2 is smaller than 3, so we just add the 4 to our result, okay? And then the next nodes, what we do. So after we do the 4, so we can see 4 don't have any nodes, right? So we don't have a kind of recursion. So we just return to here, and then we check the left node. In this case, we don't have a left node, so we return to here. And then we will check the left node of 1. So the left node of 1 is 2. So we are going to check 2. So the depth for the tree nodes 2 is 2. And the result size here is 3, right? So we already had a 1, 3, 4. So the result size is not smaller than the depth. That means that's not the first value in the current in this level. So we don't have to add anything to our result because we just need the first one. And then we will check the 2 have a right child or not. So in this way, yes, we have right child, so it's going to be 5. And then the depth of 5 is 3. and then the current result of the size is 3. It's not smaller than that. So that's why we don't have to offer the 5 to our result. We only offer the first one. Because the first one is the rightmost one. We are doing the reversed DFS. We start from right part. So we are doing start from here. We recursively do call this DFS helper function, and then we recursively call this one, and then we return, we call the left one. After we call the left one, we call the right one. So it's kind of this way, right? So the time complexity for this problem is going to be ON because we traversed every single node only once, right? And then the space complexity will be ON. OH. OH is going to be the hat, okay? So it's gonna be here, okay? Okay, so it's OH. Okay, let's start coding. So for this problem, first, what we do, we will declare a list for integer, and the name is result. So we are going to put our result to here, okay? So at the beginning is empty. Oh, sorry about that. So what we're gonna do, we're gonna go this one to outside of our method. Okay, so start from here first. We need a result. The result, we need a new array list. Okay, and then we need a helper function. The helper function, the first node we're gonna put is a root, and the depth for the root is 1. Okay, and then what we do, we just return the result. Okay, gonna return our result. And then what we do here, we do the helper function, the private void helper. Okay, so what we do, we have a tree node. Okay, we have int depth. Okay, and then if nodes equals to none. Okay, we just simply return. And if the result size smaller than the depth, that means this is the first tree nodes we are going to we are traversed the first nodes of this current level, and is from right to left because we are doing reversed. Okay, from here we can see the next step. I'm going to put helper. See, I'm putting helper, right? Helper node dot left. No. We start from right. Okay, and then depth plus 1. This basically, and the helper node dot left depth plus 1. Okay, let's check the code. Let's run the code first. Okay, it's accept. So let's see this one. So start from here. This is our result. It's gonna be a array list. Okay. So start from the helper function. We use the root as the input, and the depth here is 1. And then we start the helper function. When we check the result, the size smaller than the depth, that means the first nodes in the current level. And then we will add the first node to our result. This is basically here. But the first node is going to be the right child of the node, not left. Okay, so we have to put the node the right first because we are getting the right side. We are trying to get the rightmost tree node. Okay, okay, let's submit the code. After we submit the code, let's see what's going to happen. Okay, so our code is 100% faster than others, okay, than the Java Online submissions. Okay, thank you for watching. I will see you next time.